Welcome to another podcast. In this episode, we're going to be taking a look at how to calculate descriptive statistics once again in MathStudio. It's the same problem as the previous video on the grouped mean, although this time we're going to be focused on trying to find the grouped standard deviation. And I know I said grouped standard deviation, but we have, if you look over here to the bottom of the screen, we have a formula for the grouped variance. And so if I want the grouped standard deviation, that is SXF, that turns out to actually be the square root of the grouped variance. And so I'm going to use this formula. Let me box it up here. I'm going to use this nice formula that we have to be able to find the grouped variance. And then I'm going to take the square root of the answer that I get out of that in order to find the standard deviation. So this is the grouped standard deviation. This is one of the harder formulas to actually do by hand. We looked at it in a video. We had to create several columns. We had to create a column for x squared f and then xf, and then we had to square that. And so there's a lot of stuff we did by hand. I want to look at how to do this in MathStudio. Now, just to go over a little bit of what some of the pieces of this formula are, if we were trying to translate this to MathStudio, something like n would be represented by the sum of the f. That's what n is. N is equal to the number of total responses, number of total data points, and remember f once again is the frequency and x once again is the data, and so we're going to have to enter those values in before we can do anything on this problem. All right, let me go ahead and pull in our calculator window and we'll take a look at it together. So for this particular problem, I'm going to shrink it down a little bit. I won't have the sidebar, but if you watched the previous video, I'm pulling all of these out of the catalog, so all of the commands that I'm using. We're going to start by setting x equal to the data set 1, 2, 3, 4, 5, just as in the last video. And we're going to set the frequency to 12, 8, 42, 32, and 27. So we've got our data set and the associated frequencies defined. Now, if we want to calculate the grouped variance, then there's going to be a lot of parentheses here because I'm basically trying to take this formula that's boxed and represent it in the calculator. So let's do it this way. Let me go ahead and calculate what the sum of f is. The sum of the frequencies is 121, so that is our n value. Okay. In fact, I can go ahead and call that n. N is equal to the sum of f. And now if I want the grouped variance, that is 1 divided by n minus 1 times the sum, and the times button here is the asterisk, times the sum, and I probably should capitalize sum. I think it allows you to do it either way. I had it lowercase here, but I'm going to capitalize it because that's the way it's written in the catalog. But sum of x squared times f minus, and so here's where I have to be a little creative with my parentheses. I have one parenthesis for the fraction and then one parenthesis for the sum in the top. So it's going to be the sum of x times f squared divided by n. So actually I want one more set of parentheses here. So I've got the sum in a parentheses, I've got the squared in a parentheses, that's the numerator, and then n is in the denominator, and I'll close off the parentheses. It's nice because it color codes the parentheses for you, so you can see, for example, that that parenthesis matches up with that parenthesis and closes that fraction altogether. Finally, I need to close the blue parenthesis here, and so if I do one more parenthesis, it knows to close it with the blue. And so that is a representation. So this formula is a representation of the formula that we have in the box here. And so if I hit enter, it should give me the value that I'm looking for. And so one small mistake I made, though, I have to keep this n minus 1 in the bottom. The reason I knew I made a mistake here, and this is good that this happened so I can show you, we ended up with a negative value here. You should not end up with negative values on these problems. The reason is I'm about to take a square root of it. You can't take the square root of a negative number. So the n minus 1 needs to be grouped here in the bottom to show that's in the bottom of a fraction. Okay, if I recalculate, now this looks much better. If I recalculate, I have this value. And so if I take the square root then, the square root you can do a couple of different ways. There's a square root button here, so I could do the square root of, and the best way to do it is just tell it to do the square root of the answer. And the answer is right here below it. So the square root of our answer doesn't like that. Well, let me try it this way then. How about the square root of answer to number 4? Doesn't like that either. Well, tell you what, how about we just do square root of 1.4325? 0.68871. That's not the easiest thing in the world to do, but it's at least a way to go ahead and get it in there. I think on your iPads that should work, though. I think the desktop has a little bit of a bug with that. But you should be able to just say square root of answer or use the square root of answer button on your iPad to get the result there. Regardless, the point is, here is our formula for the grouped variance. And then on the very next line, we've calculated the square root of that, which means that this number is the grouped standard deviation. So for this problem, our group standard deviation is 1.19 or 1.2 if we're rounding. For this problem, the nice thing, just like it was with the grouped mean, is I don't have to change this once I have it in place. In fact, one of the things you can do is save a copy of this file and then reference it each and every time that you want to do group standard deviation. Just name the file group standard deviation. And then all you have to do is, for whatever problem you're working, go in and change x, go in and change f, recalculate both of those, recalculate the size or the number of frequencies, and then just recalculate each of these, and it'll update based on the new numbers. You'll have to, if you did it this way, you'll have to change whatever number pops up here, you'll have to change and put it in here. But you won't have to memorize this formula. If you save it into your calculator, you can just pull it up each and every time. All right, thank you for watching.